Good day everyone, my name is Wei Yao Liang and my friend here Tam Hong Fan, and we are from the 13th group, and today we're gonna present to you about chronic kidney disease. So the main goal of this presentation is to predict whether a patient has a CKD or chronic kidney disease or not. We have our advisor is Tai Mingxun 老师. Okay, next slide. So the content of this presentation we divided into four parts. I will be responsible for the introduction and the data pre-processing, and my friend here is going to explain about the creating models and the conclusion of the presentation. Next, research purpose and background. Number one, our purpose is to provide patients early diagnosis so that the doctor would not wait until the patient already got to the chronic stage. And number two, we can use our skill that we learn from class and practice applying it to the real data and provide real prediction. So here is our fish diagram. So the fish head is the main problem of our presentation, is to know if a patient has a CKD or chronic kidney disease. We take a look at four main branches, which is lifestyle, medical history, medical condition, and genetics. Let's start from medical history. So under the medical history, we have heart disease. Is if the patient has heart disease or no heart disease, diabetes, if the patient has diabetes or not, is there any minerals present in the urine, does the patient is obese, and does the patient has a high blood pressure or not, lifestyle, does the patient smoke or the patient don't smoke, genetics, does the patient have a relative who are diagnosed with kidney disease or not, and then we finally take a look at the medical condition. We take the measurement of red blood cells, white blood cells, and we take the measurement of blood pressure and how old is the patient. All of this attribute we take it and predict, fit it into our machine learning models. Okay. Next is our introduction to our dataset. So our dataset name is chronic kidney disease dataset. We get it from Kaggle, and we have 25 features in our dataset, or 25 columns. The target of this dataset is the class column, which contains CKD or no CKD. CKD means you're sick, you have chronic kidney disease. No CKD means you're fine. The size of our dataset is 400. We have 400 rows in our dataset. Okay, next. We have 25 columns in this dataset. This is the list of our columns. You can pause the video if you like to take a look at each of the columns. And yeah, I can carry on to my presentation. Next is data preprocessing. On the left hand side here, you can see our dataset presented into a data frame format. You can see here, this is the columns and this is the rows. We have 400 rows and 25 columns, but here you can see there's a lot of no null values. We have not present here, NaN here, NaN here. The next, and then on the right hand side here we can see each of the columns and each column's data type. We have H is in float format, blood pressure is float, and this is, they also count for the non-null data. So we have 400 data. We have, for the H column, we have 391 non-null values, so we have 9 missing values, and we will later sort that out. Okay, here, number 15, 16, and 17, those columns is numbers, but the data type is objects. So first things first, we should change that data into float. We use the toNumeric function here. Okay, next we split the data into numbers and category, and I will explain later on in this presentation why we decided to split the data into two. But what I'm gonna show you here is, in our data we have a lot of typing error, like here, yes, no, space, yes, /t, no, Space yes means yes, slash t no means no. So we first sort the typing error first. And then here, so numbers data is it's numbers, it's integers or float like 10, 15, 27, etc. etc. Categories data is like string. There are string. There are category like normal, high, low, positive, negative, etc. etc. Okay, next. So this is how we manage to sort out the typing error. We manually input the error value, and then put in the correct values like slash t no into no, slash t yes into yes, space yes into yes. Use the replace function here. And then next we map the target. The class column is our target. You have ckd becomes 0, not ckd becomes 1. Okay, after checking there is still no values, so we this is an example. In the diabetes mellitus column we have still a null value that we must fix that. Okay, so this is the method that we decided to fix the null value. Number one is to fill with the mode, or fill with the most occurring data. And next, and number two is we fill with the average, or fill with the mean of the column. So this is why we divide our data into two categories, category data and numbers data. So we fill the category data with the most occurring value, or with mode. So we dot fillna mode. And then for the numbers data, we fill the null values with the mean, with the average. So this is the before and after we fill the null values. If you type df.isNull.sum, you can see here all the null values of each of our columns. This is before we fill the data, and after we fill the null values, we can see we have no more null values here. Everything is 0. So that is good. We can carry on. And then the next thing we should do is label encoder. We code, we label each of our column, which is in the category data. It becomes numbers like 0 and 1. We use label encoder, so high and low becomes 0 and 1. Present and not present becomes 0 and 1. For example, if low, medium, and high, it might become 0, 1, and 2. Next is we check each of our columns information gain. So here I printed out all the info gain of our columns, and we decided to take the least information gain, which is bacteria, coronary artery, and post cell clumps. Here, bacteria we have only 0.026, which is very small. Coronary artery also 0.024, which is smaller, and the post cell is 0.05. So because it is very small, it means meaning that it contribute the least information to our data, so therefore we will drop those columns. So our pre-processing is pretty much done here. Before pre-processing we have 25 columns in our data set, and then now we have 22 with no more missing values, and we already label each of the category data, and we also label the class, the target. Okay.
Okay, so now I'm gonna explain about the models that we use to predict this chronic kidney disease dataset. So we choose three of the models, which is decision tree, random forest, and naive Bayes. And then before we jump into the models, we have to make the train test split first, because it is gonna be used for the input to each model. And basically what it does is we split the dataset into two parts, where the four-fifth of the dataset gonna be used for the training part, and then 1/5 of it gonna be used for test, and then the training is gonna be used for the machine to learn what is going on with the dataset, what gonna be predict and extra. And for the test, it's gonna be used to test the machine whether it's already learning at the good pace, and then what is the result of it. And then we jump to the next part, which is decision tree classifier, where the accuracy already got around 96%, which is already great for a machine learning. And here we can see that it predict correctly for the someone who got the chronic kidney disease about 48 case, and then 29 case where it predict correctly that someone is not got the chronic kidney disease. And whereas this 2 and 1 case is actually the false prediction from the machine. And then go to the next part is this is the result of the decision tree, where it give a branch that it basically give us the way where to go based on the features that we got. And then go to the next part, which is the random forest classifier. And quick explanation about this. This is an assemble learning method that operates by constructing a multitude of decision trees at training time. And then it basically make a multiple decision tree and choose the most trees as the result. And then we can see that the accuracy is much higher compared to the decision tree. And then it's only got one case wrong for the not chronic kidney disease case. And then go to the next part is naive Bayes classifier, which already got 95%. It is not seems a good choice, but we have to see if it is using the PCA. And what is PCA? PCA is basically a pre-processing method where it reduces the dimension of the dataset. For example, in here we are using 25 features or dimension. It is quite a lot for a machine to comprehend. So we have to reduce the dimension for the machine to learn much quicker and much more accurate to calculate the result. And we hopefully comparing to the pre-processing set where they are not using PCA, we hope that the accuracy gonna improve a lot. And then jump into the next one. Before we use the PCA, we have to scaling the data, because our data is basically, for example, the numeric data. They got a different scale of each column. For example, the age may be 17 to 80, and then the blood pressure may be 120 to 180, maybe something like that. And then the scale of each number is not different, and it have to be scaled before we put it into the PCA. And here we are using the minimum and maximum scalar, which is it using the between 0 and 1 number. So we can see here the age, the blood pressure is around 0 and 1 number. And then here's the PCA. We are using 0.9 as it is the variance that we want it to be. And then we have to make a new train test split for the PCA. And then we can see that the accuracy of decision tree is up for 1%, and then this random forest is got the 100% accuracy prediction. And then naive Bayes we can see it's up 4%, which is up to 99% accuracy. And then here's the table of comparison here. So for the most significant one is the naive Bayes after PCA got 4% difference, but we have to choose the random forest PCA because it got 100% prediction, which is it is good for doctors to use it. And then we jump into the conclusion here that as seen that PCA can really improve the dataset to be more accurate to be calculated by the models, and then the random forest using PCA would be the best method to predict chronic kidney disease. And then from us is actually for the data pre-processing process, the most problem for this dataset is that there are a lot of missing values, but we just fill it with using the mode and the main function. But we think that it is not really good for dataset to having a lot of missing value. And then that is from us. Thank you for your guys' attention.